All right, so this screencast seeks to address the last part of Chapter 3, which includes ecosystem disturbance, resistance and resilience, and ecosystem services. So let's talk a little bit about ecosystem disturbance. Ecosystem disturbance is, is any physical, chemical, or biological agent that changes a population or community within an ecosystem. These disturbances can be man-made or anthropogenic, such as logging, urbanization, deforestation, air pollution, or these disturbances can be natural, such as fire, wind, blizzard, and drought. Scientists often study these disturbances and how they affect the cycling of energy and matter in an ecosystem. They also seek to use these disturbances to study how quickly these systems bounce back after, after a disturbance. So instead of using a huge area to study the effects of ecosystem disturbances on biogeochemical cycling, a lot of scientists use smaller areas. And one sort of natural area to look at is a watershed. A watershed is all of the land in a given area that drains into a body of surface water. Um, Here is a map of the St. Johns River watershed. So any drop of water in the form of rain that hits the land that you see right here eventually finds its way into the St. Johns River. This watershed can be divided up into different basins. So you have St. Mary's Basin or Nassau River Basin, and these smaller divisions of the watershed can be studied at even smaller scales. One of the most famous watershed studies is at Hubbard Brook Ecological Center in New Hampshire. They monitored the biogeochemical cycling of 6 watersheds since 1962. Here's one of the experiments that they looked at. They clear-cut one watershed and left one intact as a control. They compared the nutrient runoff from the clear-cut watershed to the control watershed, and they were looking particularly at nitrates, so part of the nitrogen cycle. 6 months after the clear cut, the stream and the clear cut area showed significant more nitrates in the water compared to the control. So this study helped this environmental scientist determine that without trees to take up excess nitrates from the soil, the excess nitrates will find their way into a river. Next, we'll talk a little bit about resistance versus resilience. Resistance is a measure of how much a disturbance can affect the flow of energy and matter versus resilience, which is the rate at which a system can return to a steady. Um, Resistance and resilience are common in many ecosystems. It's normal and natural in many ecosystems. In fact, Florida forests have evolved with fire disturbances for thousands of years. They depend on periodic forest fires coming through to sort of keep the ecosystem healthy. There's one tree called the longleaf pine that can only germinate or grow if the seed itself has been burned by fire, and it's the top tree or the climax as part of the climax community of the forest. If we suppress these systems, like in the case of Florida, biodiversity can actually start to decline. The animals that evolved to live and the plants that evolved to live in ecosystems that have fire can no longer live there. If we light the forest on fire over and over and over again, well, then that will kill a lot of the species except for the hardiest of the individuals. So biodiversity will still decrease. So what we should manage for is what has evolved in Florida forests for thousands of years, which is sort of an intermediate level of disturbance, right? And that leads us to what's called the intermediate disturbance hypothesis. All right, sorry. The intermediate disturbance hypothesis states that biodiversity is highest at an intermediate level of disturbance. Too low, you don't have that too low of and frequent of a disturbance. Only the best competitors, which can outcompete most species, can survive right here. And if you have too frequent of a disturbance, it will kill most species except those that have evolved to live in super harsh conditions. So the best ecosystems tend to have the ecosystems with the highest biodiversity tends to be ecosystems with a moderate or intermediate amount of disturbance. So right about right here. Last but not least, we're going to talk a little bit about ecosystem services. You have 4 different types of ecosystem services. You have provisions, which are goods that we can actually use, such as wood, lumber, food crops. And then you also have regulating services, such as storing carbon. So trees doing photosynthesis can actually store carbon within living tissues, so that relates back to gross primary productivity and net primary productivity as well. We have support through mainly through pollination. And then last but not least, we have cultural, so things like education, recreation, and aesthetic values. Ecosystem services are simply what nature provides to us for free. So I'll leave you with this thought. All right, think about your now your newfound understanding of how systems work, and think about golf courses. Right, what have we humans done to natural systems when we put a golf course down? Why have golf courses traditionally had a bleak environmental record? What has been done to change this record, and how has that affected the biogeochemical cycles where these golf courses are built? Questions about this will be on the quiz and will be on the test, so make sure you listened. I hope you listened to this, and I hope you took some notes. Have a good day. See you later. Bye.